All right, we're going to go ahead and get started here in the dev track. This is Matt Johnson. He works for Packet-Tide, EE Harbor, which is it?
Yeah.
Both.
Yep.
So he's going to be talking about securing yourself, company, website. Don't be a dummy. So Matt Johnson.
Cool. All right. So welcome. Welcome to my talk. Here's a little about me. My name's Matt Johnson. I'm from upstate New York. This is a picture of my wife and I. We just got married a little over a year ago. We both enjoy rock climbing and hiking and really just seeing the world and being outside. Might be a little bit of a stereotype break for developers, but I know a lot of people like getting outside and hiking and all that. So we also both play in a band. We play in a band with Madison Vandenberg. We're both musicians, and she just got out of American Idol. She did, I think, 3rd place. So that's kind of been taking up a lot of time lately, but those are some things about me, some things I enjoy. As far as cybersecurity goes, I've always really enjoyed cybersecurity. Since I was a kid, I was involved in like hacking culture in a way. As a teenager, I was decompiling my parents' like parental control software to give me more time on the computer after school. That's just always been something I really enjoyed. In college, I studied computer science, and from there, they had a cyber defense program. So I was heavily involved in that, and we ended up competing in a lot of competitions nationally and different ranked competitions, and that was always really fun for me. We ended up traveling a bit to do some national competitions that we qualified for, and we did 2nd place in the nation at some point in my senior year. So I was the president of the Cyber Defense Club, total nerd, but this is just a little background. This is something I enjoy. This is going to be a little bit of a different talk. I'm planning on showing a bunch of demos, but I currently work for Packet-Tide. I'm a developer, and we own EE Harbor, so we do a lot of add-ons. You guys probably all know us for that. I spent a lot of time working on the add-ons, upgrading them alongside Jace, who some of you might be more familiar with. I do pop into Slack from time to time, but not really nearly as much as Jace does. But I personally do a lot of expression engine upgrades, and this is something that kind of spurred this talk a little bit, just because I do work with a lot of sites that are older, that were built a long time ago, that do not have any, I guess I should say, cybersecurity like mindset. And it really is a problem. I've probably seen most of the attacks that I'm going to go through. I've probably seen pretty much all of them. So this is kind of what spurred the talk. So let's get started. Okay, so the way sites were built 10 years ago, it's just not the way they should be built now. People are more aware of exploits. There's a lot more hackers out there. This kind of stuff is getting like more and more popular. A lot of these exploits that are out there, they're not hard to do also. They used to be a little harder, some of them, but now there's tools, and hackers know these tools. They know them well. And so like just because you don't know how a thing can be exploited doesn't mean it can't. And just because you don't see like how far it can go doesn't mean it can't be very detrimental to your servers or your sites or your clients. This is all built on trust, so your clients trust you, and if their site is hacked, that's your fault. So it affects the bottom line, it affects your clients. So should you really care about this? Yes, you should. So I know a lot of developers will say, well, this is just like a brochure website. I don't have to worry about security. Even if your site isn't accepting usernames and passwords or isn't doing e-commerce, security is still a factor that really matters. The reality is that you don't know if you're a target. Data is a huge asset to hackers. And again, security builds trust between you and your client and the client and their users. So it's just something that should be on the forefront of our minds. So I'm going to go through, I guess, from the other side, what the hacker is going to be trying to do and like how they're going to exploit different vulnerabilities on your website. So this is just kind of a... So one thing I'd say is just to invest in your education. If you are listening as a business owner, invest in your developer's education. This will go a long way, just being aware of what's out there. There are a lot of free tools, a lot of really inexpensive tools, and there's a lot of information out there now. I'm going to keep pointing back to OWASP. OWASP is a organization that publishes a lot of resources about this, and I'll get into that in a minute. But so my goals are, I hope everyone comes away with a broader understanding of how it works, how hacking works, and what people are doing. And I hope people learn how to secure their sites a little more when working on things. And I also hope that my examples kind of shock you, like you realize what is out there. So OWASP is the Open Web Application Security Project. They have lots of resources, I just mentioned them, but they have a top 10 list of web application vulnerabilities that they think are the most pertinent to that time. So every few years they come out with that. The latest one is the OWASP Top 10 2017. And here's what they have on their list for 2017. A lot of these things I'm going to be going through, but this is also a very much overview of things, but you could just imagine where things will go, I guess. So one thing on there is running old versions of software. And we all know this is an easy thing to fix, and sometimes it's a really hard thing to fix. But I do think it's really important to plan maintenance times to patch your old software. I know sometimes it's very costly, but it will save you money in the long run, especially if you get hacked and your client's upset and their user data's out there. Now you're in the news. You just don't want to be in that situation. So just kind of always be on top of that, be aware. There are a few websites that list out vulnerabilities, and Monday I pulled this number. They had 121,999 vulnerabilities listed. And this is the kind of thing that hackers all know about. They're CVEs, which stand for Common Vulnerabilities and Exposures. And there's databases out there that you can search for things based on software involved, the version, type of vulnerability, known exploits, date published, even the complexity. So if you want to find something that's easy to exploit, you can filter by those things and then just kind of look around on the web for that type of thing out there. I pulled a few numbers. These are the known vulnerabilities by product. And this is, I think, a little eye-opening. It's also not an entirely fair list. Obviously, Apple has more people attacking their operating system than Expression Engine. And a lot of vulnerabilities also get patched and never disclosed. A lot of them are counted here, but they're very low impact or they're similar to other ones. So this is just kind of an idea of that. So I would encourage everyone to use one of these sites and just kind of look at what's out there. So how do we fix this? You update your software, move people to newer servers, get on the latest version. I know there were exploits out there for Expression Engine 2. You might not want to be running that anymore. It's old software. It was deprecated a long time ago, several years ago. So if you have sites still on Expression Engine 2, you should get off that, as well as any other old software. So cross-site scripting, this is a huge topic. I barely have enough time to scratch the surface on this, and I bet most of you have some understanding of what it is, but how serious is it? So let's jump into it and define things so we're all on the same page. Cross-site scripting attacks are a type of injection in which malicious scripts are injected into otherwise benign and trusted websites. So cross-site scripting attacks occur when the attacker uses a web application to send malicious code, generally in the form of a browser-side script, to a different end user. Flaws that allow these attacks to succeed are quite widespread and occur anywhere a web application uses input from a user within the output it generates without validating or encoding it. So this can allow session cookies to be compromised. It can allow someone to prompt a user to install stuff. An example I pulled from WASP was a pharmaceutical site that could allow an attacker to modify the dosage information, which would result in an overdose. So it can be a really big deal, even on like a site that doesn't do login type things. It can also just be like a pivot point for an attacker. So they can use cross-site scripting to get into your browser and start doing things as you. So there are a few ways this is exploited. File upload is one of them. So anywhere you have a file upload spot on your website, if you're accepting resumes or images, you should always validate those. So if you are accepting HTML, for example, then you have a file on your website that's going to be able to execute JavaScript, and that's a cross-site scripting attack. I have a quick demo here. This is a web application, and it was built to be insecure. So it's easy to exploit it, but basically, and you can't see any of that. So I have this file. It's an HTML file, and all it does is it has a script tag and an alert. And this particular upload is supposed to be for like a PDF or something, but they don't validate that. And so this is just an example file upload, cross-site scripting. I'm going to upload that here. And now we have this URL where the file is found. And this could be sent to someone, or it could be included somewhere. And right here we have our document cookies printed out. So that's just an example. So does this really happen? And the answer is yes, it happens all the time. This is one of the most common exploits out there. So this is an example from Slack. There's a website called hackerone.com where companies like Slack and all these big companies are out there. Expression Engine is on there as well, where you can disclose your bugs that you find and your vulnerabilities that you find, and they'll pay a bounty to you for it, or they'll just say thanks and they'll fix it. But it's a way to privately disclose things. And this was a bug in Slack, where if you uploaded a file called, with that as the title, SVG onload alert 1, and then sent it to someone, basically it would run JavaScript in their Slack. And this was disclosed in April of 2019. So they paid a bounty of, I think, $500 for this. Stored cross-site scripting is a different kind of cross-site scripting, but it's the same thing when it boils down to it. This is a vulnerability that exists when the injected script is stored on the server. So the attack commonly targets websites that allow users to share content, such as forums, social networks, blogs, message boards. It's possible for the attacker to embed their script using HTML in a comment or post. The malicious script will run anytime the page is opened. So if you get this on a forum page or something like that, anyone who visits that page now is compromised, and their browser can be taken over, or you can execute attacks like based as that user. So here's another example. And so I'm going to go and edit my profile, and I'm going to set my profile color to, this is a tag. Oh no, actually I think it's in snippets. So this should be sanitized. I'm posting an A tag with a on mouse over event, which is going to execute that JavaScript code. And now on this web app, I posted the snippet. Looks like we have a link, and if I mouse over that, we've got a pop-up. So this obviously could be much worse, and it could execute right when it loaded. I could do an onload event, but that's just a simple example. So does this happen? And the answer is yes. This is an example from PayPal, and this was actually just disclosed in August. And the person who found this was paid a bounty of $20,000 because it was a pretty big deal. Basically, you could send something to PayPal and it would be stored in the cache. And then when a user visited the sign-in page, it would execute the attacker's JavaScript. So that's a pretty big deal. It could affect their entire user base. It could have been very costly for PayPal. But yeah, this happens all the time. It happens to the big players. It happens to the small people. So this is always an issue. Reflected cross-site scripting is also different. It occurs when an exploitable code is injected in an HTTP response. So the injected script is not stored on the server, but it impacts users who are lured into opening a malicious link. So this is also easily demonstrated. If I go to a URL, say that's not there. Here's a 404 page. This is pretty common. Everyone's got one. And it's going to tell me that this wasn't found. And if I type in something else, it's also not found. But what you'll notice is that on this page, it's printing out whatever you put into that URL. So this is an example. If it's not sanitized, this would be an example of a stored cross-site scripting attack. So let's see if I can find this. I think it's there. So if I send someone this link now, JavaScript's going to execute in their browser again, and it's just because I put JavaScript in the URL. So this is a problem. People see a link to PayPal or to wherever, and they think, okay, this is a website I trust. I can click on this, and this happens also all the time in real life as well. So this is an example from Uber where it's not going to play. So this I just pulled right off of the HackerOne report, but they're giving a demo of what they did to exploit it, and they also got a bounty of, I think, like $3,000 for reporting this. Where their JavaScript essentially loaded on the Uber page. And so this is also a huge problem, obviously. So, of course, I can make a pop-up on your browser, but is this really a big deal? I mean, some of your sites you don't even care if a session is stolen because the user can't do anything. I mean, some of these sites you think that it just doesn't matter. And for this, I have another demo. So this is a pretty commonly known tool. It's called BEEF. Stands for the Browser Exploitation Framework. And on the left, I have Kali Linux, which is a Linux distribution that just comes with a bunch of tools for pen testers, and it's pretty commonly used. So I'm starting the browser exploitation framework, and then we've got a site here that has been compromised. So all we did was we have a script tag that says load this file on my server. So now the user goes to this website. It's just, I pulled this template off something. It was a free template. And they're just browsing this, this website. But the attacker now has their browser hooked. And this is an online session right here. These are different. Oh, this is going to be hard to do because I can't see that. But, so from here, these are all different things I can run on the web server. I mean, on the client's browser. There we go. So, first thing, I'm going to, let's see. On the hook browser, I'm going to say, let's see if we can get a cookie. And run that. It's not visible. Sorry, 1 second. OK, so this is just a simple thing. We can grab a cookie from the user's browser. We can get the page HTML if we want to. And this is all the HTML from the page the user is on. This kind of stuff like isn't hard to do. I can replace all the hrefs on the page to a thing, so they click on that. I can redirect them. So let's see. I don't know where the redirect one is. So this is a tool that hackers will use to basically force the user into doing something or get data that they want out of their browser. And essentially, you can control their whole browser using this. So here's an example. This is called the petty theft module. I'm just going to put in my hacker box IP here. And so now you'll see on the user side, they see, oh, my Facebook session timed out. And this could look legitimate if it's a site that's using single sign-on or something, and the user doesn't know what this means. So they say, OK, my email, Gmail, and password. And let's see, Firefox is going to try to tell me that this is not secure. Oh, yeah, definitely is. But now if I click log in and go back to the attacker side, I have the email and the password they typed in. So this is the kind of thing that can come up. And I know probably a lot of developers here won't fall for this sort of thing. They'll say, this isn't Facebook. I'm not typing this in. But I also know my mom will fall for this. And a lot of my friends will. So this is just kind of a demonstration. There's so many things you can do here. This is the fake flash update script. And so I can basically point to a payload that I want the user to download now. And I'm going to put my IP in again. and then I click execute, and then now on this site, this is just some demo, maybe like a business card kind of site. Now it's saying you need Flash to do this, and a lot of users are just going to say, okay, install, and there we go. Now we downloaded this thing that I told them to download, and it's kind of a social engineering trick, but the fact that you can push this sort of thing to the browser, it's kind of a big deal. So I know most people will click that sort of thing and they will install it, and now the hacker has a reverse shell that's going back to their machine, and they've just got root access on your machine or user level access. But from there, you're out of the browser and you can get all sorts of files off their thing. And using this, I can send things to their local printers. I can scan their network. So I can use their box to send a denial of service request to someone. So say I have 50 people who I've hooked right now. I can have them all start denial of servicing someone, and it's coming from the browser. So it's never going to come back to the attacker. So this is a big deal. Cross-site scripting can be very dangerous. This is just a few things that you can do, and obviously this is a demo site, but it is a pretty big deal. So, or the other way. Also, if anyone cares, there is a Chrome extension called Vegan, which defeats the beef framework. So it'll make it so you as a user can never be hooked. So it's kind of interesting. Of course, someone made that.
Hey man.
Yeah.
How do you hook each other?
Oh, okay. Yeah. So just by visiting that page, they were hooked. So if I visit, say I go to a different page, this is my list of online browsers, and in a minute this will go to a zombie browser. So it's offline. So, and I can show you actually the code. I've got that right here. I can't see this either. Well, essentially, I'm just including that JavaScript file on this page. And so in a cross-site scripting scenario, it could be done in all sorts of ways. So if there's a file upload, I can have that loaded on the page. Any way that you can inject a script into their page, that's when you can have like a hook basically call back. So if there's that example where I hover over the snippet and it loads my JavaScript, instead of being hover over, I would do like onload. And instead of like alert 1, I would have it hook back to my thing. So a hacker could go through and just like put this in as many sites as they can find, and they're all over there. And then they just sit there and they've got this framework where they can do anything. And not only that, like the hacker can also, actually I'll pull this one up. There's a whole section on persistence, because once the user leaves that page, they're no longer hooked, so you can't exploit them anymore. But I can do like a create pop under, and then tell it that it's a, oh well, I'm offline now, so. So, okay, so you'll see it pop up in the online browsers in a second. Okay, so here we are. This is under test1.demo. Now if I go here and say create pop under, I'll make it a clickjack. Clickjacking is when you click on the page and it registers that as like doing whatever you want it to do, basically. So I'll execute it, and now we're a user here, and we're just going to kind of randomly click, and you can see it pop up in the corner there, and then it'll hide itself. So now, if they leave this page, that one underneath is still connected. and you can see it popped up over there. So now we've got 2 browsers hooked, and they're just the 2 different tabs that are open. So I hope that cleared up kind of how that works. But so we want to know how to beat it. So cross-site scripting prevention, basically you're going to sanitize anything the user gives you. So if they pass their name in, you got to sanitize it. If it's their age, a number, sanitize it. You never allow anything that the user typed in or uploaded to be executed on the page, basically. And this can be kind of hard because there's so many spots that this could happen. But basically, again, never trust the end user. I have it in here twice, but escape everything. So there is an OWASP cheat sheet on this, and it basically goes through like, here are some checklists, here's some things that you need to know to check. And I have a few in my slides, but we just don't have enough time, I don't think. So don't put stuff in a script tag, don't put things in an HTML comment, don't allow untrusted data in an attribute name or in a tag name. Never put it in directly in CSS. So if you, so also never obviously put JavaScript code from an untrusted source in the page. So if there's a parameter called callback that contains a JavaScript code snippet, basically no amount of escaping can fix that. So just don't do that. There is some hope. A lot of frameworks that are out there, a lot of CMSs. I know Expression Engine does this. If a user uses all the native functionality there, that's definitely taken care of. I know this is something we pay attention to and with our like EE Harbor stuff. If there's a form input, this is something that we are sanitizing. And this also, I'll talk about this in a minute, but you have to trust your developers, who you're going to work with. You got to trust the code that you're running with add-ons, or whether that's Expression Engine or Craft, WordPress, any of that. You just have to trust them because a lot of that code wasn't written by you. But the good news is that a lot of this stuff, it's really commonly known, and it's built in to most frameworks. I think I'm running short on time, but I'm just going to move as quick as I can. Client state manipulation. This is an attack when the client decides that they're going to send something that you don't expect. So here's a form, and it's a form for ordering a pizza. And you can see that there's a hidden input for the price. And of course, no user is going to be able to change a hidden input, but they can. So if I decide that I don't want to pay $10 for my pizza, but I want to pay $1.20, I'll just put it in there, click submit, and if this is not validated, this is probably going to go through. So I know I've seen sites with PayPal where they think like, oh, this is PayPal's trusted, like obviously they're going to be good. But the way it works is they're just inputting like the amount into like a hidden field. So this sort of thing is not as common anymore because the way we've been doing things in more modern web has been with tokens, and basically we've been doing it right, I guess. So I have a demo for this, but I might run out of time, so I think I'm going to skip it. Yeah, I've got more slides though. So SQL injection, this is a big one. I think most people know about SQL injection. But basically it's a technique that allows code injection in the database. So malicious SQL queries are then inserted from the client to the application, and it can result in like pretty much anything that the attacker's skill and imagination can do. So they can list out your database, or they can modify it, tamper with things, They can destroy stuff. They can spoof identities. If you have access to the database, you can pretty much do whatever you want. So this is an example on the slide, but basically we've got a form where we're posting to login.php with the username and the password. And there's nothing wrong with this so far. But then we have, and I had to squeeze it on there, but we've got some PHP code that's then going to authenticate you as the user. And basically they're taking the post data for the username and the password, putting it in a variable, and then running an SQL query. So here's that right there. And where does the data come from? Well, it comes from the user. So they're basically taking whatever the user says to do, sticking it in this query, and then they're just going to run it. There's no sanitization here at all. And this is where the problem is. And I've seen this too many times, even like lately, where basically you're just taking anything the user gives you and running it in an SQL query. So what happens if we replace the password field with a terminating single quote and then continue writing SQL? So in this case, it's going to be select star from user table where username is whatever you tell it, like maybe admin, and then password is empty or 1 equals 1. And we know 1 equals 1 is going to be true. So that's going to evaluate to true, and the user is going to be logged in, whatever username you pass. And yeah, I put that in here. This is what that query is going to look like after it goes in. And this should always be sanitized. And the dash dash at the end, that's just a comment. So anything else, the attacker doesn't know what the code is usually, but anything after that is just going to be commented out. They don't really care. Let's see. So probably a lot of you have seen this, but if you haven't, or if you haven't really understood it yet, this is Little Bobby Tables. So, love that one. And we've got another SQL, another demo here. And I don't think I even need this one. Okay, so we've got another web app here. And this is BWAP, which is a buggy web app. And so you can download this and set it up. I'd actually recommend it maybe, just for testing out this sort of thing. You can download this and try out all these different exploits just to know what's out there. And then there's also guides on fixing them in this app. So that can be like really valuable knowledge. But we've got this search for, I think it's for a movie, not sure. And I'm going to make this a little bigger. Yeah, search for a movie. So I'm going to search for the, oh no. Bug. Okay, let's try this again. If I search for the, we've got, oh no, we don't have results. Hope this works. I believe. Okay, we're on the wrong page. Cool. So now we've got results. And here's all the movies that show up. And then we're going to see if we can break this. So if I type in just SQL single quote and search, now we've got an error. And that's probably because the single quote is getting stuck in this SQL statement that is saying this, this doesn't run. There's too many single quotes. And so that's probably what this is. And we can verify that if we do So we're searching for, I don't know, SQL, which we know that that's not a movie. But, and then I do a single quote and I say, or 1 equals 1. And then I'm going to use a pound sign, which is also a comment. And now it's going to give me everything in that table. So this is a really simple SQL example, but I'm going to take it a step further because we know that this field is injectable. And it's a get parameter, so that kind of makes this easy as an example, but you could do this in kind of any way, post, whatever. And if you look at the URL, I don't think you can read that, but we've got a field up there that says title equals, and it's exactly what I typed in. So now I'm going to use a tool because no one's got time to sit here and figure out what works. And let's make this bigger, if I can. There we go. So I've got SQL map, and this is the URL. And you can see there's title equals 1. So that's kind of just an example. And this tool is going to now use that parameter to, okay, see if it's injectable. And where is my mouse? There. So maybe this is too big, but basically it's telling me that, yeah, we found that this might be injectable. So this is an example. They're doing a union and they're just figuring it out. And they're running like 200 something scripts in there just to figure it out. And now I'm going to add the, all right. So now I'm going to add a -- DBS, which is for databases. And you can see here's all my databases that are on that server. So this tool is going to automate finding these commands that will actually work. And BWAP, that's the database that has this data in it. So I'm going to take it a step further. We're going to do tables -d and BWAP. Now it's going to list out the tables. So now we've got all the tables in our database. And you can quickly see like how this is very dangerous if you've got SQL injections available on your site. But let's do some more. We've got columns. Because I can see that there's a user table, and I want to know what columns we've got. So -t for table users. Okay, so we've got all the columns from the database right there. And this is a tool, I mean, this is a different server. It doesn't know anything about, I don't have any MySQL access, and I'm still able to pull this kind of stuff. And let's go just a little bit further. So this tool, SQL map, has a feature in it where I'm gonna dump the database, the user's database. So right now it's saying we recognized a password hash in the passwords table. Do we want to keep going? Yes. And do we want to crack them? Yes, we do. And wow, that was actually really fast because this is a kind of a slow virtual machine. But it actually found the two usernames, which were AIM and B. And then, where is my mouse? Okay. Here's the password hash. And then right next to it, the password was bug. And it was able to do that really quickly, basically because they're using a or a really quick algorithm for password hashing. It's not the way you should do that. And it's also not the way people are doing it by default anymore. But it just kind of demonstrates how serious this is, I guess. And then it's also all dumped to a CSV now, and I can analyze that, or I could try to crack the passwords later if that didn't work. Okay, so SQL injection. This is a big deal. How do we prevent it? Basically, we want to sanitize any input again. This is kind of like a recurring theme, but in cybersecurity, you don't want user input to be put on the page or put in your server. You don't want to include PHP that's going to get run. You don't want to, in this case, you don't want to run SQL that they decided to run. So a lot of frameworks here are automatically doing this for you. So if you're still typing like MySQL connect, MySQL or MySQLi connect, MySQLi query, stop doing that. Expression Engine's got EEDB. I know Laravel uses whatever it uses, and Eloquent, and that's gonna protect against this. Pretty much any framework now they know about this. So use those tools and you're pretty much safe. Another way you can do it is just whitelisting. So if you know what the input's gonna be. Blacklisting is not very effective, but basically using modern tools, don't run your own PHP that's just going to say, yeah, let's take this user input and stick it right in there and we'll run it, see what happens. So cross-site request forgery. Basically, cross-site request forgery is when an attacker uses an HTTP request to access user information from a different site that they're authenticated. So these types of attacks target state-changing requests rather than data theft, since the attacker can't see the response to the forged request. So an example of this would be changing login credentials or making a purchase, maybe deleting an account, anything like that. Basically, the server isn't smart enough to see if the request was intentional or not. So if you can get a user to run this request from your site and then ping a different site, it's just going to run it. So again, like with all these, WASP has cheat sheets, and so like this is a really good tool for just referencing. But okay, so that's what I said basically. But it forces an end user to execute unwanted actions on a web application in which they're currently authenticated. So I do have a demo. I think I'm going to have to skip it. But the demo is basically from one user on my on that insecure app. I'm going to post a snippet, and the snippet is for delete snippet of index 0. And so if a different user clicks on that, they are then deleting their own snippets on accident, and they're clicking on my homepage. So basically, if you are, this is also something that's built into a lot of frameworks. If you are setting your disable CSRF flag in the config to get something to work, stop doing that. This is kind of a big deal as well. So if I know that something's vulnerable, I can then put a link somewhere else that says change my password, and then the user is going to run that. So basically, this is bad. Here's a image. Okay, so how do we defend against this? Usually with tokens or nonce. Basically, I think they're all called tokens now, but basically you want all of your requests to have a token, a unique ID. So when I run change my password, it has to have the unique ID that the server just set. If it has a different unique ID, we reject it. And so this is all something that's done in the background. The user has no idea about it. But if I as an attacker, say, when someone clicks on this link, it's going to delete their account or change their password or something like that, it's not going to run because there's a unique ID that's associated with that session. And since it wasn't just created for that form action, it's not gonna work. So I felt obligated to put this in here. Passwords, we all know this. Stop using admin. Don't use bad passwords. Use a password manager. Basically, using a bad password is giving away the keys to your site. That's all I'm going to say about it, but use a password manager. You can use Have I Been Pwned to check if you have been pwned or what passwords are out there, and it's kind of embarrassing like how much is out there now. So I need to wrap up fast, but denial of service is when, so it's basically sending a bunch of requests to something or using up resources on a server that makes it so other users can't use that server. Or sometimes you're going to crash the server. And preventing, basically prevent single points of failure. There's a lot of ways of doing this, but usually you're going to want to handle exceptions, protect overflows, limit threading, or use threading to limit like asynchronous operations. So avoid operations that are going to wait for the completion of a large task. So HTTP verb tampering. So basically, like this attack is getting less common because servers are stopping. They're not accepting these requests anymore, which is good by default. But basically, in the HTTP 1.1 spec, there are a bunch of different verbs or methods available. So we use get and post all the time, but there's also put, delete, trace, connect, head options. And this is basically if the developer is unaware that these can be run, you might not realize that an attacker can just say put file here, and it's going to upload a file to your server. You can easily check if this is enabled. You can just do like an nmap scan on your URL, and it's going to tell you what verbs it accepts. But these are just kind of things to be aware of. There's a delete verb, which it's a instruction to the server where we don't really use this anymore very often. Some APIs still do this, but if you're not aware that these things are out there, you might never even check. Just keep going. Preventing it, be aware of what's on there, restrict your HTTP methods, apply whitelisting of permitted methods, so like get and post. If you know you're never going to accept a put command, just disable it. A lot of servers nowadays are actually coming disabled because they know that this is being used. So here's some security tips in EE, and I actually just pulled these off of the Expression Engine website, so you can read them there as well. But this is what they say. Update regularly. So obviously I kind of covered this already, but limit user permissions. This is a big deal as well. So you have a lot of users on your site and you don't want to give them everything. Lock it down. Don't let them edit templates. Don't let them do what they don't have to do. And that'll really save you a lot of time and money in the long run. Use SSL certificates. A lot of the attacks that I went through become a little more tricky with SSL, and some of it is impossible to do, but specifically like SQL injection, that sort of thing, that all works with SSL. But SSL is a great tool. Everyone should use it. They're free now. You can get a certificate like easily. Use a password policy. Set minimum password lengths. Enable password lockouts, that sort of thing. Restrict file types, and we kind of covered why this is important, but you don't want people uploading HTML files to your server. or PHP files for that matter, but really anything like that. Remove unused add-ons and applications. So really this is all about trust. You don't want to have add-ons that basically they can run any PHP they want. So if the person developing the add-on decides to put something malicious in there, it's just going to run on the server. So this is kind of a big deal. Make sure you're conscious of this, and disable uploaded executables. I'm going to just skip over this. PHP and templates. So this is a screenshot directly from Expression Engine, and basically they're saying if you enable PHP in your templates, the person editing that template now can do like almost anything. So don't do that unless you absolutely have to, but again, don't do that. This is to limiting template access, but if a user decides that they're going to put this on their template, what do you think it's going to do? So this is going to make them a super admin, and they can run actually whatever SQL they want, really. So from there, they could do anything. Again, like you just kind of want to lock down your sites. So that's everything. Thank you. We might have a few minutes for questions, but
we're kind of out of time.
Okay.
But Matt will be around if you want to ask him any questions during the snack time. So
Cool.
Snacks, I haven't looked, but they're supposed to be right out here. So help yourselves with snacks, and let's give Matt a hand.